Our country is transected by the Philippine Fault Zone from the north all the way to the south, mainly as a result of the subduction along the Manila Trench and along the Philippine Trench. These faults and the subduction cause numerous earthquakes in the Philippines every day. Thus, in this lesson, we will talk about geohazards starting with the earthquakes. What is an earthquake? An earthquake is a natural geologic phenomenon caused by the sudden and rapid movement or slippage of a large volume of rock along the fractures in the Earth's crust, or which we call faults. So this discussion is very much related to our previous discussion on rock deformation, mainly because the earthquake is a manifestation of rock deformation that is um, happening continuously in the Earth's crust. So every day there are at least 1,000 of earthquakes, but most of these earthquakes we cannot feel them, but our seismic instruments do. So, parts of an earthquake. Sa earthquake, meron siyang focus and epicenter. So when you say focus, focus is the origin of an earthquake at depth. So in this illustration here, we see here the focus over here, and this is the fault line. So the focus is where the seismic waves are generated. It is where the earthquake started, and the epicenter is the point directly above the focus on the surface of the earth. So usually when we look at when we look at news and we look at PHIVOLCS data, yung nire-report nila usually is epicenter. Because ito yung nakikita natin sa surface. Ang epicenter ay nasa may barangay, something sa munisipyo, something sa probinsya ng something. Now, active faults, these are the faults that move during the past 10,000 years. So in geologic time, it is fairly recent time, 10,000 years, very, very young lang yan. So these are the faults that move the last 10,000 years. So paano nalaman na nag-move siya the last 10,000 years? Mainly on records, historical records. You can also look at the soil profile or kung meron bang mga streams na displaced like what we've discussed before. And then, there's also a potentially active fault. These are the faults that have movement during the last 1.65 million years. So, ibig sabihin, ito yung mga faults that were preserved in the rocks or preserved in maybe soil pa rin, pero medyo matanda na sila. Like, they are older than 10,000 years, wala silang masyadong active movement in recent time. Whereas in active faults, these are the faults na wala talagang movement during the past 1.65 years and they are preserved in the rock record. So why do we have active faults and then we have potentially active and inactive? Because our tectonics is very dynamic that sometimes nagsishift yung areas where they're active faulting, and then there's also areas that were seismically active before, tectonically active before, but then after many, many millions of years of tectonic processes, they will become stable. And thus, yung mga previously active faults ay magiging inactive after millions and millions of years. One important concept that we have to understand when studying earthquakes is the elastic rebound theory. So elastic rebound theory describes how rocks deform. So here in this figure, there is this original position of the rock, and because of tectonic forces, this rock can deform due to the buildup of strain. So recall from our previous discussion in rock deformation, yung stress natin, which is the tectonic forces, they will build up on the crust and thus will induce strain in the rock. So there is a buildup of strain at this point. But then, after many, many years of buildup of strain, that rock can rupture. So this, at this point, we have here the brittle deformation of rock. So once that rock rupture, magkakaroon ng release of earthquake or release of seismic waves, release of energy, thus causing an earthquake in an area. So shown here is an animation of the elastic rebound theory. So initially, this is the original position, and then nagbe-build up yung strain slowly, and after quite some time, the ground will rupture, thus causing the release of energy, which will eventually cause earthquakes. So the energy that is released from the ground rupture is in the form of seismic waves. So when energy is released, it is propagated as seismic waves. And shown here is a seismogram. So a seismogram is a record of seismic waves in a certain location. So shown here in the illustration, this is the focus of the earthquake where the earthquake was generated, and the seismic waves can propagate along the surface as surface waves or within the earth as body waves. So we have here two types of body waves illustrated, the P wave or the primary wave and the S wave or the secondary wave. And shown here also in this figure is the seismograph. The seismograph is the instrument that can record and detect seismic waves. There are two types of seismic waves. One is the body waves and the other one is the surface waves. So body waves, these are the waves that emanate from the focus in all directions through the interior of the earth and gives us a character of the different layers of the earth. So basically, si body wave, siya yung seismic waves na kayang dumaan sa loob ng earth. And there are two types of body waves, the primary wave and the secondary wave. So from the term itself, primary wave, sila yung wave na nauuna sa ating mga seismic station. So siya yung pinakamabilis na wave. And then secondary wave, sila naman yung second na dumarating sa seismic station. So sila yung mas mabagal lang ng konti sa primary waves. So in terms of the type of medium in which they can travel, primary waves can travel in solids and liquids, whereas secondary waves can only travel in solids. And then the primary waves move in a push and pull motion. We also call these longitudinal waves. Push and pull yung motion niya. So you can imagine a slinky. Kapag pinaglalaroan yung slinky, um, push and pull yung motion ng mga particles ng slinky. And primary waves, like what I've said before, is faster than S waves. Whereas secondary waves or S waves are a bit slower than primary waves, and these waves are transverse waves. So when you say transverse waves, the movement of the particles are perpendicular with respect to the direction of wave propagation. So if the wave goes towards this direction, the materials or the particles of the earth are moving perpendicular up and down, perpendicular with respect to the direction of the wave movement. So the characteristics of primary waves and secondary waves are very important in terms of imaging the Earth's interior. So sila mainly yung ginamit natin para malaman kung gaano kakapal yung bawat layers ng Earth. So the other type of seismic wave is what we call the surface waves. Surface waves are the waves that travel along paths restricted to the Earth's surface. So if the body waves are the waves that can travel through the Earth's interior, the surface waves, sila yung mga waves na sa surface lang ng Earth nagta-travel. And these directly affects us during earthquakes. So yung mga waves na mainly nararamdaman natin kapag nag-earthquake ay mga surface waves. Surface waves are further divided into Rayleigh waves and love waves. So, Rayleigh waves, ito yung mga waves na cyclical up and down yung movement. So, if this is the wave propagation, the particles are moving in a cyclic manner, like this one. So, para talaga siyang alon na nakikita natin sa dalampasigan. Whereas love waves, these are the waves that move in a cyclical side-to-side manner. So love waves, if this is the direction of propagation, the direction of the particle movements are side to side. So this is another illustration of Rayleigh waves and love waves. So this is the highway. Rayleigh waves will move in a wave-like manner, the wave that we know when we are looking at the beach, ganyang wave. And then the love waves naman are moving in this manner here, left and right, with respect to the propagation of the love wave. Now, how do we detect these seismic waves? Paano ba natin nalalaman kung alin yung body, alin yung surface waves, and what is their importance when we are studying earthquakes? We detect seismic waves using seismographs. So these are the instruments that can record earthquake waves, producing records of movement called seismograms. And this instrument is very valuable for seismologists. Seismology is basically the study of earthquake waves and how these earthquakes um, can visualize the interior of the earth. So this is an example of a seismograph wherein meron ka ditong support and the weight, and kapag umuuga siya, therefore uuga rin itong what do you call this? Itong weight na ito, and then you have here yung panulat, and as the ground is making uga, magpa-plot siya ng waves here in this rotating drum. So it's a very simple instrument, but it can give us a lot of information about earthquakes, about the interior of the earth. So take note that the instrument is called seismograph, whereas the graph itself is what we call the seismogram. So instrument is seismograph, yung graph ng earthquake or ng waves over here is what we call the seismogram. So shown here is an example of seismograms. We have here the P wave. So kita natin yung P wave, siya yung nauuna. And this over here, this interval is 1 minute. Kasi nga, di ba, nagro-rotate constantly yung rotating drum natin. So, kapag nakaka-detect siya ng earthquake, nagkakaroon dito ng sulat, and of course, this interval in between the sulats is constant. Itong interval na to, based on the rotation of the rotating drum. So, here are 3 seismograms in 3 different stations. And this space here, in between the 2 red lines, signifies 1 minute. Okay, so in India, unang dumating si P wave at this point in time. P wave followed by S wave. So kita natin P wave is the weakest wave, pero siya yung pinakauna, and it is the fastest wave, followed by S waves. And then after quite some time, we have here the presence of the surface wave. So itong malalaki na, these are surface waves. And then we have here another seismogram and another seismogram. So why do we have 3 seismograms here? When locating epicenter, we need at least 3 seismic stations. Okay, so what does this tell us? Ano bang sinasabi ng seismogram? Basically, yung distance in between the first P wave and the first S wave can tell us kung gaano kalayo yung seismic station with respect to the epicenter. Okay? So this distance here, or yung time interval in between the arrival of the first P wave and the first S wave, can tell us how far the seismic station is from the epicenter of the earthquake. For example, here we have a graph showing the time on the y-axis and the distance on the x-axis. And this is the S-wave curve and the P-wave curve. So, for example, in the seismograms that I've shown earlier, meron tayong na-detect na 5-minute time interval in between the arrival of S-wave and P-wave. So, here, we will look at the area at which 5-minute yung pagitan nilang dalawa. So, andito siya banda sa line na ito, and we will just project that all the way to the x-axis, and we will be able to get the distance of the seismic station from the epicenter based on the difference in the time of arrival of P wave and S wave. So, kung 5 minutes yung difference nila, dito siya maglaland, and the reading over here is 3,400 kilometers. So actually, this is the reading for the Nagpur seismic station. And then, this circle here signifies the set of points that are all 3,400 kilometers away from this seismic station. So again, this circle here is a set of points that are 3,400 kilometers away from this station. So if we are only using one seismic station, yung epicenter natin can lie on any point along the circle. And thus, the importance of using two more seismic stations. So, if ginawa natin yung same process with another seismic station in Darwin, we will be able to get another circle over here. And as you can see, if we are going to look at the green circle and the blue circle, magkakaroon siya ng dalawang intersection. So from there, you will be able to narrow down your seismic stations. It's either here or here. Or rather, you will be able to narrow down the epicenter. It's either here or here. So, dalawa pa rin siya and medyo magkalayo. And thus, the importance of using a third seismic station. So, the third seismic station is here in Paris. It's 82,000 or 8,200 kilometers away from the epicenter. And this is the set of points that are 8,200 kilometers away from Paris. So, using these three, once na nag-intersect itong three circles mo, you will be able to locate the epicenter of the earthquake. But of course, this process is already automated in many seismic stations all over the world. So that's why mabilis lang yung pag-report natin ng epicenter and magnitude. Now, the seismic waves are very important because this is the main tool that we were able to use in order to visualize the interior of the Earth. So, just a brief overview kung paano siya ginawa. So, this one, so for example, meron ka ditong seismic source. Can be earthquake or a volcanic eruption or whatever. So, magkakaroon ka ng generation of seismic waves over here. So, magge-generate ka ng S and P waves. And from that seismic event, magpo-propagate yung S and P waves in different parts of the Earth. But then, there are some parts that will be able to detect S and P waves, both S and P waves. May portions na shadow zone. These are the zones that cannot detect S waves and very, very weak P waves lang yung kayang i-detect. And here in this portion, only P waves are felt. So, one way to explain such phenomenon is that the waves are being refracted within the Earth. So, nagkakaroon ng refraction, reflection, and many, many other processes. And of course, this also takes into account that S waves can only travel through solids. So, meron tayong mga refraction dito, and refraction only occurs if there is a distinct boundary between two units. So, in this case, nagkakaroon ng refraction dito because this is the boundary in between the mantle and the outer core. So, using the same thought process, bakit walang nadedetect dito, bakit may mga nadedetect dito, using those, they were able to come up with the layers of the Earth, with depths, and the type of boundary in between the layers. So, shown here is the graph. So, on the y-axis is the depth, and on the x-axis is the velocity. And here is a graph of the velocity of S waves and P waves. And kita natin that in some portions, in boundaries in between layers of the Earth, nagkakaroon tayo ng retardation of seismic waves. And sometimes, meron ding rapid increase in seismic waves. So this is another diagram showing the increase and decrease in seismic waves, which signifies the different layers of the Earth. So what are the causes of earthquakes? Again, pwedeng tectonic because of plate movement related to the deformation of the Earth's lithosphere. Pwede rin tayong magkaroon ng volcanic earthquake. So, kung merong magma na gumagalaw underneath, and kapag yung magma na to ay nag-rise towards the surface, that rise of magma or movement of magma can cause fracturing in rocks. Also, human activity can induce up to some extent seismicity in an area. So, for example, nagkaroon ka ng additional load in the crust via construction of dams, or merong high pressure fluid pumping or what we call fracking. Kasi in the petroleum, if you want to extract oil or natural gas, you have to crack the rock para mag-rise yung natural gas to the surface and para mas madali mo siyang ma-extract. So, such process can also induce seismicity and then underground nuclear testing and those things. So, these are some of the human activity that can induce seismicity. But as far as I know, yung seismicity na ini-induce nila is not that significant. Parang low energy lang siya. Shown here is the map of the world's earthquakes. So, sobrang daming earthquakes natin sa buong mundo and they are mostly felt along, of course, the plate boundaries where there are many, many tectonic processes that are operating. When we are measuring earthquakes, we use intensity and magnitude. So what is the difference between intensity and magnitude? Intensity is basically a measure of ground shaking at a given locality based on the amount of damage. So itong si intensity describes kung ano yung nararamdaman in a certain portion. Gaano kasira yung area, gaano karaming buildings, or nararamdaman ba yung earthquake, ano yung mga nararamdaman ng mga tao dun sa area. So basically, those things will determine kung ano yung intensity, and the type of scale that we use for intensity is the modified Mercalli scale. So here is the modified Mercalli scale, and as you can see, yung scale niya is mostly on structures, like intensity 10, many structures destroyed, ground is badly cracked. Intensity 6, felt by all, many people run outdoors, furniture moves, slight damage occurs. So, ito yung nararamdaman doon sa certain area. And then, we also have the Philippine Earthquake Intensity Scale. So, medyo similar din naman siya sa Modified Mercalli Scale, but it is designed na para mas maging appropriate for our country. Okay. So, the other type or another way to measure the energy or earthquakes is via magnitude. So if we are measuring the amount of destruction in intensity, sa magnitude naman, what we are measuring is the amount of energy that is released at the source of an earthquake. So gaano karaming energy yung na-release doon sa earthquake area mo. So, how do we get the amount of energy? Mainly from the amount of area that is displaced, the length of rupture, or the bulk modulus. So, this one, si magnitude, hindi siya nakabase sa location mo kasi what it measures is the amount of energy, whereas the intensity, what it measures is ano yung lakas ng earthquake na nararamdaman sa isang location. So, what we use in magnitude is the Richter scale. Richter scale is this one over here, 2.5, generally not felt, 6 destructive, 7 major earthquake. So, the thing about Richter scale is that yung measurement niya is exponential. So here on the y-axis at the left is the magnitude. So magnitude 2, 3, 4, 5, 6, 7, 8, 9, 10. And here on the other y-axis is the amount of energy released at a certain magnitude. So for example, if magnitude 2 yung earthquake mo, yung ma-release niyang energy is around 56 kilograms. Tapos dito naman, magnitude 6, around 56 million kilograms amount of explosive. So, kita natin yung increase ng energy release is exponential, and in particular it's around times 32. So for example, the amount of energy in magnitude 3 is 32 times higher than that of magnitude 2 earthquake. So si magnitude 4 naman is 32 times higher than magnitude 3 and 32 times higher than magnitude 2. So, ganon. So, exponential yung increase ng energy natin sa ating Richter scale. So, shown here is the notable earthquakes in this graph, and this is the number of earthquakes per year worldwide at a certain magnitude. So, for example, magnitude 5 point something Long Island earthquake. 1884 is here. And the amount of energy of that earthquake is actually larger than an average tornado. Now, here is the amount of energy of the Hiroshima atomic bomb. So, very infamous Hiroshima atomic bomb. And then, may mga earthquakes tayo that are plotted higher than the Hiroshima atomic bomb over here. So, imagine ganun kalaki yung energy na kayang i-release ng ating mga earthquakes. So, we also have here the fairly recent Japan 2011 earthquake, laki ng destruction. And this earthquake is even stronger, or in a sense, mas maraming energy na nare-release niya than the Mount St. Helens eruption or the world's largest nuclear test by the USSR. So these are just some of the photos that are results of ground shaking. So si earthquake, it induces ground shaking. Kapag nagka-earthquake sa isang area na walang buildings, walang bundok, patag lang naman, at andun ka sa area na yon, wala namang panganib sa paligid. So, it's not going to be a disaster because wala namang nakapalibot na building sa'yo. Siguro uga-uga ka lang for quite some time, tapos na. But then, if you live in an area where there are a lot of buildings, where there are very steep slopes that can collapse any moment during an earthquake, that is when earthquakes become very, very dangerous. So, ano yung mga effects na pwedeng mangyari because of an earthquake? So, for example, pwede tayong magkaroon ng landslide. So, this is an example of the 2008 landslide in China. And as you can see here, kitang-kita mo yung area kung saan nag-collapse yung bundok mainly because of the earthquake. So, the earthquake, because the ground is shaking, the ground was moving, nangyayari is nagiging unstable yung soil sa mga hill slopes natin, and that can cause collapse, causing a landslide in an area. There can also be flooding due to earthquake, especially if there is a dam failure. So, meron kang dam na naghaharang ng maraming tubig, and if that dam fails, and it will release a lot of water downstream, the rivers cannot carry those water instantly. So, yung mangyayari is babaha dun sa area. And this is 2011 earthquake in Japan. Nagkaroon ng liquefaction and ground subsidence in some areas. So, because of the shaking, yung mga sediments here, yung mga sediments dito, nagkakaroon ng liquefaction or nagiging parang liquid-like siya, and thus causing ground subsidence in some areas. And of course, kapag nagkaroon ka ng earthquake and tinamaan yung mga lines mo, and then yung mga pipelines, electric wires, and so on, that can also cause fire in an area. Another hazard is tsunami. So, tsunami, these are a series of water waves caused by displacement of a large volume of body of water, usually in ocean, though also it can occur in large lakes. So, ito yung mga malalaki nating alon na we have a Filipino term for tsunami. So, ito yung mga malalaking alon natin that is caused by an earthquake. So, paano ba na-form ang tsunami natin? So, here, this is the ground rupture site. And because of the release of energy here and the displacement of the crust, magkakaroon ng upward wave, magkakaroon ng initial upward movement. And this initial upward movement can propagate all the way to the coast. So, here in the deeper portions, hindi siya masyadong ramdam. Parang may konting waves ka lang. But the thing is, when these waves approaches the coast, wherein mas mababaw na yung area, yung nangyayari is, magbe-break itong waves na to, forming very, very high waves, which we then call tsunamis. And these tsunamis will hit the coast and can enter or can go inland, like kilometers inland, depende sa kung gaano kalaki yung tsunami natin. So, this is an example of a tsunami event. And in Ufble, I have uploaded a case in the 2011 Japan earthquake, which is a tsunami-genic earthquake na kapag-generate siya ng napakalaking tsunami which caused billions and billions of destruction, and a lot of lives were lost during that 2011 tsunami. Shown here is the map of deadliest earthquake since 1900s. So over here in number 1 is the Haiti earthquake, magnitude 7 with 316,000 deaths. So sobrang dami. A little bit higher than magnitude 7. So hindi siya little bit actually kasi nga 'di ba against exponential yung ating Richter scale. So 7.5 magnitude China earthquake, 242,000 deaths, and then magnitude 9.1 Sumatra, India earthquake. So actually, ito yung isa sa mga pinakamalakas in terms of magnitude. Pero yung death toll niya is 227,000. So Haiti, even though mas mahina siya, mas marami pa rin yung number of deaths. And some other earthquakes are plotted over here, and we have one here in the Philippines. Shown here is the animation of the wave propagation during the magnitude 9.1 Indonesia earthquake. So dito, galing sa epicenter, kita natin yung movement ng waves, literally the waves in the ocean, the tsunami, and it has affected multiple areas over here and over here. So meron sa Thailand, naramdaman ng Thailand and India yung tsunami, and over here in Western or Eastern Africa rather. There's also the 2010 Haiti earthquake. So there in Haiti, there are around 46,000 to 316,000 deaths. And kita natin dito yung destruction. Sobrang laki talaga yung destruction because of the earthquake. Here naman is the 2011 Tohoku or Japan earthquake and tsunami. So the earthquake over here generated tsunami, and that tsunami affected the coast of Japan, especially this coast over here, and a lot of lives and buildings were lost during that event. 15,561 deaths and a lot of injured and missing. And isang important event dito is yung pagkasira ng Fukushima power plant. And because yung tsunami, naabot niya yung cooling system ng power plant. Wala yung cooling system, it's very hot, and thus sumabog yung power plant. Thus causing radioactive stuff to go out in the environment, and because of that, hindi na pwedeng tirhan yung Fukushima area because it's highly radioactive. Now, in the Philippines naman, we have what we call the big one. So very famous yung big one because in Manila, we have the Marikina Valley Fault System, and there are a lot of infrastructure and buildings, and not to mention many buildings that were not compliant with the building code. So if magkakaroon tayo ng big one, we can expect that it will be disastrous. So this question, ano ba yung sagot sa when is the big one, and how do we answer this question? So we have ways to predict earthquake, but then yung earthquake prediction natin is mainly a long-term prediction, and many scientists are still exploring how can we possibly predict earthquake in short term. So here, a prediction means anticipating the time, place, and magnitude of a large earthquake within a narrow window and within a high enough probability that preparation for its effects can be undertaken. But then, earthquake prediction is very hard, very difficult, because ang hirap maghanap ng precursor sa earthquake. Mahirap maghanap ng signs na magkakaroon ng earthquake sa isang area. So what are the signs that scientists look at in order to quote-unquote predict earthquake? One is increased seismicity and strain. And then radon emission. So there are researches on radon emissions that some earthquakes can have certain radon emission signals, and that can be a precursor before an earthquake. Pero it's still highly uncertain. In one of the journals na sinasabi is, yung radon emission, although earthquakes can significantly have radon emissions prior to ground rupture, however, yung background radon emissions also can be confused with earthquake-induced radon emissions. There's also electromagnetic signals, animal behavior, fractoluminescence, satellite observation, changes in seismic velocity, electrical resistivity, and changes in groundwater levels and chemistry. So here, this is the San Andreas, and this one is the big one in San Andreas, which is highly anticipated as well. So kasi si San Andreas meron din siyang due date, and many scientists are figuring out how to predict this due date of the San Andreas fault. In Tohoku earthquake, 2011 Tohoku earthquake, Japan. Although Japan is experiencing earthquake every day, very highly seismic din yung Japan eh. So very well developed din yung earthquake research nila. However, they weren't able to predict this very high magnitude main shock of the Tohoku earthquake. There were four shocks, and there were aftershocks of the four shocks. So this guys here, merong mga earthquakes na before the main shock. But then mahirap talagang i-predict if this earthquake is already the main earthquake or is it just a foreshock for another main event. So may mga ganon. And then, some scientists are also looking at seismic gaps. So seismic gaps, ito yung area na parang wala masyadong seismicity. So ito, seismic, and ito, very high yung seismicity, pero dito, bakit kaya nawawala ng seismicity? So that is one of the questions that has to be answered by many scientists. So itong mga seismic gaps, tinitignan din nila yan. And then, this is what I was talking about, radon emissions. Up to some extent, pwede magkaroon ng radon emissions prior to an earthquake, so like this one. But then, some scientists have said that the Earth can have a background radon emissions. Radon anomalies of non-tectonic origin also exist, and this can look strikingly similar to tectonic radon emissions. So, mahirap pa rin using radon. Other evidences or other precursors can be fractoluminescence. So, ito yung medyo slight na paglow ng ating mga bato. There's also the animal behavior. These are the frogs before the 2008 earthquake in China. So, may mga ganong possible precursors. And many scientists have deployed various satellites for earthquake monitoring. So, ito, yung dinedetect nila is the differences in electromagnetic in the area, electromagnetic emissions. So, yun yung ginagawa ng mga satellites na to, ng Demeter microsatellite, QuakeSat, and so on. And like we have previously discussed numerous times, in the Philippines, we have a lot of earthquakes and a lot of hazards, and these are the plots of the volcanoes, and these are the plots of the earthquakes. And of course, in terms of earthquake record, marami tayong maipagyayabang because marami tayong mga high magnitude earthquakes as well. So we have the 1976 Moro Gulf earthquake, which is the magnitude 8 earthquake, 1990 Bohol, 1990 Luzon, and 1992 Mindanao, 1994 Mindoro, 2002 Sultan Kudarat, and some fairly recent, 2012 Negros, 2013 Bohol, 2019 Luzon. This one is the 1976 Moro Gulf earthquake, and it is a highly destructive earthquake na nagkaroon ng tsunami generated in the Gulf of Moro in Celebesi, and it killed about 8,000 people in these areas over here. So this is one of the worst earthquake and tsunami disaster in the Philippines. There's also the 1980 Bohol earthquake, which is also tsunami-genic earthquake, and the 1992 Eastern Mindanao tsunami-genic earthquake as well. So this portion here is a cove wherein in this area they were able to experience 6-meter high tsunami. And in fairly recent history, we have the 1990 Luzon earthquake. Its magnitude 7.8, and the epicenter is in Nueva Ecija. So, the epicenter is in Nueva Ecija, and as you can see here, kitang-kita yung napakagandang ground rupture, which is a left lateral strike slip fault. And approximately 94 kilometers away from the epicenter is this destruction in the Hyatt Hotel in Baguio. So, this is a very high-class hotel, and because of that 1990 earthquake, maraming namatay at maraming naipit dito sa hotel na to. So, shown here are some of the ground ruptures as recorded by FIVOC. So, this is the Digdig fault. Ito yung fault na nag-move nung 1990 Luzon earthquake. And then there's also the 2012 Negros Oriental earthquake, which is magnitude 6.9. And because of that earthquake, nagkaroon ng landslide which buried a community over here. And in some areas, they were able to document uplifts. So, kita natin dito, itong portion na to which was previously submerged ay nasa land na mainly because tumaas yung area. And then we also have here the 2013 Bohol earthquake. So in this portion, maraming mga swarms of earthquake. But then here is the main shock, which is the magnitude 7.2 earthquake, which left 222 dead and 73,000 structures ay na-damage ng earthquake. And then this is the fault scarp ng 2013 Bohol earthquake. So kita natin dito yung movement ng lupa. So, imagine, itong area na to at itong area na to ay pantay before. And this is the human force scale. So, yun. Kita natin yung amount of displacement. Malaki talaga. And one effect also is this one, the Lubok Church in Bohol. So, kita natin yung destruction ng church and course collapse. May mga collapse ng certain areas din sa Bohol. Yan. And of course, there is also a coastal uplift. So, kita natin na tumaas yung land na ito. And of course, yung Chocolate Hills ay naging chocolate na because of landslides. And then, major recent is the 2019 Luzon earthquake in August 22. So, it's a magnitude 6.1 earthquake which caused the collapse of this supermarket over here. So imagine this is what 1, 2, 3, 4 floors, and that 4 floors became like this after the Luzon earthquake. So here in Chuzon, in Porac, Pampanga, the ground here is mainly pyroclastic in material, mainly because of Mount Pinatubo pyroclastic deposits. So, yung mga pyroclastic deposits, lahar, and many other stuff sa Mount Pinatubo, yun yung underlying lithology dito sa area na to. And because it is not well consolidated, those type of material actually exacerbates the seismic waves or the earthquake that can be felt in this area. So, kaya here in Pampanga, relatively malaki yung destruction compared sa Zambales kung saan yung epicenter ng earthquake. Now, one important question is, are we prepared for the big one? Metro Manila, big one earthquake, Marikina Valley Fault, pwede siyang mag-rupture anytime soon. Soon being pwedeng bukas, pwedeng next week, but pwedeng many years from now. Or even hundreds of years from now. We don't know. We are highly uncertain when is it, but again, it's better to be prepared. So here is the West Marikina Valley Fault System. So this is the Marikina River and many subdivisions and many infrastructures in Metro Manila. Here is an earthquake risk map of Metro Manila. So itong mga red areas, yung very high risk. And then, this is the high risk area, yung yellow, followed by green, which is low risk, and very low risk naman itong orange areas. So, paano natin na-delineate kung alin yung high risk, alin yung low risk, and so on. So, one way to identify the risk is based on the type of lithology ng area natin. So, for example, yung very high-risk areas, ito yung areas that consist of loose material. So, the loose materials can exacerbate the ground shaking. Whereas, yung very low-risk area, ito yung mga areas na bedrock, so buong bato, yung nasa area. So, mainly yung Quezon City area, itong mga nasa gitna. Ito ay mga bedrock, and then we expect bedrock to be less prone to shaking. So that's it for our lecture on the earthquake part of our geohazard lecture. In Ovle, I've uploaded multiple supplementary materials, but I want you to focus on these two. So these are compilations of articles and videos of the Great Tohoku Earthquake 2011, Great Tohoku Earthquake, and compilation on materials of Philippine earthquakes. So next week, we will talk about other geohazards such as volcanic hazards, landslides, and flooding.